Hi, welcome back. So we're in chapter 3. You must know the outline of derivatives and integrals. In some previous sections, we actually discovered the idea of transforming a certain problem into the language of mathematics, and we encountered with a problem with a sold number of tickets at certain price. And I'm going to show you how the actual use of derivative, for example, as the first pillar of calculus can be at handy in this situation. So to remind you, the actual problem was I have a total earn concerning a price of a ticket multiplied by the total number of ticket. If I set my price at 30, I guarantee to sell 50 tickets. In other words, if you draw this as the earn, in terms of the price, this line here that I see, it represents actually the coefficient of 50. Also, you can represent the x-axis here. Instead of using the price, maybe we could use the total number of tickets. We've been introduced to a new kind of rule. It says that if you reduce the price by one step, for example, like I say, it becomes 29, you guarantee there are 5 extra tickets are going to be sold. So it's going to be 55. And that will affect, of course, total earn on the other hand. So it's going to be like kind of 1595. The idea is we need to capture this. I am introducing completely a new kind of a line. I will call it line of S. And I know that this S has range only up to 30. Now I'm going to investigate this a new factor in terms of actually the first variable. Let's take, for example, in terms of the price. The maximum price I have, according to this problem here, price of 30. If this is 29, this is going to be 1. If this is 2, this is going to be 28. So obviously we have got a line here. It looks like this. What is the function of this line? It just minus us, that's it. However, what we see here from this line, that we are at intercept of 30 because we were restricted from the beginning. So we're going to add here 30 as the intercept. Let's translate this in new variable S in terms of the total number of tickets. So as it turns out, this says that every step I am moving towards the S, right, I am earning extra 5 on the T. So I got 5 and then you got 10. This is a kind of a positive kind of a line. Let's first of all define the function, which is equal every 5 I'm earning in the Y happens by change of 1 on the S is equal to 5S. To find this number is a simple, I just like say, multiply this 5 by 30, which is going to be 150. So this is going to be 150. Of course, don't forget that we got already 50 tickets from the very beginning, but should be starting from, say 50. It should look like this. Now we got new functions. These two constant or ratios, they become actually function on their own. So if we substitute these two functions, this equation here represent the actual earn. So if I want to graph this, it's quite obvious to be a quadratic equation. You know, let me just bring the function of the price in terms of the S, that somewhere along this line, a certain price, I don't know where exactly on this line, and this price will be the best price I could charge in order to make a maximum profit. And this reflected also in the total number of tickets. I mean, according to this number of steps I'm moving, here is the step again. It's just exactly the same, which actually corresponding exactly number of steps. I stop here at this, like say as naught, which will tell you what is the price and how many tickets corresponding to this price multiplied by them together. It represents the maxima of this equation or quadratic equation. I hope now things are making sense to you. So what is S naught? To answer this question from the perspective of derivative, let's say, I know one fact that according to the idea of a tangent of a line of a function, that, for example, I'm going to find at this point here in this equation, a tangent line. This slope is negative, this slope is positive, and so on. But there is one slope here, it is 0, which is going to correspond to the best earn. So I hope this image is quite clear to you. The question is how to capture this slope of this line. Now what I could do, I could follow my manual way of investigation by getting, for example, little step of edges we did before, a very small step of edge, right? Add it to the x, subtract from my x, and then get a certain value which corresponds to the slope, and then I know the slope. So check, the slope is 0, no. So move again to the another point and move again to another point. How about if we find the framework we spoke about by getting the derivative of this function, which is going to be equal, and I know one thing about it, must equal here 0. So make simple arrangement is equal to 10. We'll get this one absolutely going to be only 10 step. So my price is going to be equal to 20. My total number of ticket, 100 ticket. So the total maximum earn I can get is 2,000. Let's go to one more problem where we can see how we can actually use the integrals. Let's say, for example, in a certain hospital, the manager of that hospital wanted to actually investigate the total number of patients get in and out of the hospital in a given working day of 2 shifts. So finally, say after sometimes he come to utilize his understanding of the language of mathematics to actually draw an equation that represent the rate of change of number of customers getting in and out of the hospital in that given day. So he managed to draw this. I think now getting to create your own function or equation, you should be quite a bit familiar. We have done so many examples so far to get you to that level. Anyway, so what is this telling me? If I look at, for example, this particular hour, I will get the value here, which is actually extracted from here given a certain hour, right? This number does not indicate that we have, like, for example, say 25. Doesn't mean 25%. No, I'm talking that at this particular hour, a rate of change of people getting in and out of the hospital at this time at 25 people per hour. I mean, you start in the morning at the first shift, maybe there are fixed number of people are waiting, and then you start to serve them, other are coming, other getting out and out, and say you get like a certain peak in the day, and then again start to reduce maybe until the evening shift, until, like you say, closing shift somehow. You see, from this equation actually you can get in around to find out a lot of things. For example, what is the maximum number of people per hour during a given day, or what rate of change of people at the peak time. But say the problem here, the actually manager wanted to find out something else. Say, for example, there are 2 shifts, right, in from this equation during one day working day. Say one shift were claiming that they are serving more people than the other shift given that time, so they wanted like to make some changes, and he wanted to investigate 2 important questions. The first thing, he wanted to find actually the total number of people who get in and out a certain period of time. So, for example, he decided to figure out from this particular given time, like say T0 up to this particular time, like say T1, he wanted to find out the total number of people who actually visited at this given time. This is the first thing he wanted to answer. And the second thing he wanted to know, the total number of people. So this, we're talking about this. So this is a periodic one. And this one is going to be the total number of people who visited the hospital on that given day over 2 shifts. Let's start with the first one. What does that really mean? At this particular time, I will get the rate of change in that time, say 25 people per hour. That means at this given time, I should have another equation here, represent actually the actual number of people given again time. So at this time, the total number of people were what? This time, total number of people were what? And so on and so forth. So I hope to get an equation looks like exactly this. Of course, it's not going to be quadratic since this is a quadratic. We expect that when we want to upgrade this, it should be higher in the power, but you will understand why and why. And if I know this, actually solving this becomes quite a bit easy. Why? Because you are asking me from T0 to T1, so what I have to get, just come to T0 here and T1 here, right? And then I find out what are the numbers, sum these are together. Now from a geometrical perspective, you know what does that mean? It means I just need to find out the area under this particular region. That is the actual meaning of integral. So to get the integral of this function from, we said 10 to 15, 2 by 3 plus 4 over 2 t squared plus 5t plus some constant value. So this is the actual integrals. We started from this. If you integrate this, it will be 1 power plus. If you derive this, it will be 1 power lower. So I hope now the idea of integral and derivative, since they are the inverse of each other, is quite clear to you. Anyway, so if you figure out the way to plug in, of course, first the value of 10 inside here and subtract from the value of 15, you will get a certain value. The answer would be around 433 people were actually served from the hour 10 to the hour 15 here. So I'm going to graph this equation, right? Now, the actual integral of this rate of a change that we've done before, I mean, this line here, right? This is the rate of change. This equation in the cubic form, it looks like this. In the first hour, we serve. In the second hour, we get like 18 people we served. In the third hour, we get like 34 people were served. So in 3 hours, how many people? So what we had to do, just like to sum up these total numbers. So how can we make sense of this number, given the fact that we know the rate of a change from the previous equation, I mean, the red color here. We've seen that, for example, the first hour, the rate of change should be 8.8. What is this 8.8 to do with the 0.7? It's the actual slope of the tangent line that pass through this one. This is the tangent line. So in other words, this rate of change represents the actual slopes of the line. I hope the idea is quite clear to you. We wanted actually to know the total number of people who get into the hospital between 10 and 15. We had like 400 people or so. To confirm that, let me get back to the actual function that represents the number of people. This is my 10 hour, like 316, and the 15 hour, 750. Now, if you subtract 750 from the other numbers, 300, you will get to our answer of 433 people. And the second thing is that the total number of people visited, and how to do that, just to change the integral from 0 to 21. And that will be around 1,604 patient. Now, what we can say that with this information, the use of integrals, the idea of integrals, or where we can use them and utilize them, is quite clear to you. Now, by the end of this section, we are ready now to move to the next important outline, and it's to understand the meaning of matrix, eigenvalue, and eigenvectors. That's exactly what we're going to do next. I will see you then.